Hello and good morning. Thank you so much for coming and joining me here in my shop today for I think the second day on this radio. And wasn't in my shop yesterday. I'll explain that in a minute or two. But what I hope to do today is find out why, when I hooked up the A supply, the current draw from the radio was basically 100%, as if there was a short across this battery. A short in the heater circuits or something like that going on in the radio. I then tested the tubes, see if there was any shorted out tubes. There aren't. In fact, the tubes all tested fairly well. You see a couple of them sitting there. So what's next? The next step will be to a couple things. One is extract the chassis out of the metal cabinet here, out of the box. And secondly, study the schematic and try to come up with a hypothesis about why there appears to be a short. Is there a capacitor there that could be shorted and that could be doing it? Excuse me. And of course, in the longer run, once the chassis is out, start changing older capacitors. You can see one of them right here. So I don't think anybody's ever done anything to this radio. So why wasn't I in here yesterday? So yesterday, before I came in here, I thought, oh, you know what, the sink is draining slow in our kitchen, so I'm going to get out my plunger and give it a plunge. That plunged me into a 3-hour journey of trying to unblock my sink drain unsuccessfully, including a snake. I have a drain snake, just a manual one, not a power one or anything like that, just kind of a push it down type snake. I got 8 feet of that snake into the drain pipe in my kitchen before it wouldn't go any further. Now, why that is exactly, I don't know. It's 8 feet into the pipe. Could be the snake's getting caught, or it could be that's where the blockage is. In any case, absolutely zero success, and that was my day yesterday. So, and while I'm talking about personal challenges and pipes getting clogged, I've complained in the last number of videos about wax in my ears and how it was blocking my hearing quite seriously. Well, I got a device, maybe I'll show it to you later in this video, to help me dig the wax out of my ears. What? Yeah, dig it out. Anyway, I won't go into that right now, but it is an interesting little gizmo that may actually have a role here in my shop occasionally, which I'll explain later. Okay, so first thing, should we take a moment and verify that there was a problem here? Some of the tubes are out. Oh, the pins on this one are bent. Probably been trying to put it in or take it out in this little space here. I probably bent them. Yeah, you know what? There's a test right there. Let me pop out the other 2 tubes. And we'll repeat the current draw test. Okay, so there's the 4 tubes out. Now, how did I do it last time? I put it through my meter. I put it through this meter. This meter. This one. Put this onto milliamps. We're plugged into the amp scale here because actually we got to do this on the amp scale because last time it was over an amp draw from this battery. Okay, I'm going to attach this to the other terminal of the battery. The door switch is off, so nothing should happen on that meter. Okay, we're on the battery terminal and making sure this is not shorted. I'm going to hold it like this. Here we go. What does the meter say? There it is again. 1.2 amps from that battery. So the short circuit certainly has nothing to do with these tubes. It has something to do with the circuit or something. It has something to do with something. Okay, so to take this out, I've already taken a look in here. There are 4 corner screws. Actually, they're nuts. They look pretty small. Are they quarters? No, they're smaller than that. Uh-oh, that's... I'm sure this will be too small. Uh-oh. Well, I'm going to have to find the right size. So can you even get a nut driver down in there? No, you can, but this isn't the right size. This is way too big. I have to find the right size of nut driver and get down there. How many things in life go this way? So 3 of those came out pretty easy. Here's one right here. Here's another one. Just with this into the corners, but here it's not going to fit. So, well, you know, this is loose enough now. Maybe it. Okay, I've made it fit. Okay, the radio should come out. Why is it not coming out at all? Okay, I see 2 flathead screws up here, but you know, they don't look like, they look like they're, what are they doing? So there's a bracket here that's spot welded. Oh, did I take out the wrong screws? Or I just have to do these 2 more. I think it's just 2 more. Got a bigger screwdriver here. Here it is. I could have done this with a quarter socket, I think. Now, is that loosening it up? I think so. There's some more stuff spot welded to the side of the inside of the cabinet here. This one come right out. Solid as can be. It's as if I haven't done anything to it. So there's a bracket here and a screw there, but you know, it's the same thing with, you know what? This comes out the front. I think this comes out the front. Now, would it? Yes, it does. Don't break that. Don't break that. Just got to get this screw now. I still remember the first time I managed to take a telephone apart. An old classic Northern Electric, here in Canada, Northern Electric telephone. It was a, I think it might have been a Princess style telephone. And for the longest time, I could not get it apart until I found where the phone cable came out of the back of the phone. If you pushed it hard enough, bent it up, you'd reveal the screw. They'd hidden the screw there, where I remember how excited I was that I had discovered the secret. Oh, those telephone guys. I don't think I'm going to lift it out. Dump it out. Oh, okay, that's not quite what I expected. That's not quite it. You know what? I did not have to take these corner screws out to do that. These corner nuts are holding the front panel on. So the front panel is going to come off, I think. You can see the switch action. Oh, broken wire. Found a broken wire. Jim's found a broken wire. Right there. Right there. That's going to be the reason for everything going wrong in this radio. A broken wire. It would have to have shorted out to cause the battery drain we saw. So it must have been laying in here on a short, because there's no way you can break a wire, have it open, and cause a short circuit. Okay, well now we got the radio out to look at. What do we see here? 1, 2, 3, 4. This looks like positive end on it. 5, 6. This one there's probably okay. Just a few capacitors to change out. Everything looks okay otherwise in there. Well, you know what I could do? I solder this wire back, and how does this? So no, these are the antenna connections. This is not the on-off switch. This is the antenna connections. So that didn't cause the draw of current. The switch is just inside here. Okay, next plan was to look at the schematic anyway and start getting more familiar with the circuitry itself, some of the specifics of it. And one of them will be, how would you get a short on the heater circuit? So we'll take a look at that next. Okay, let's take a look at the schematic here. The battery that's seeing the short is this one, the A battery. And so we see one side, the negative side of it is just to the ground, and the ground is connected to all kinds of stuff in here. So the chassis, I should say ground, the chassis is utilized throughout this radio. That's what it appears like. Okay, the other side comes up. Okay, it basically feeds this line across the top of the schematic here and comes down into the filament connection. These are quite rightly called filaments. Filament usually refers to a cathodeless tube, where the actual heating filament surface is used as the electron emission surface, if you like. So what do we got here? So it comes across and goes to ground on the other side. Okay, so it's on the other side here. There's some other connection here. What does that say? I don't know what that says. It's not hooked up to anything. It's on the other side of the heater anyway, so it can't be a short. The short would have to be right on this line. Oh my gosh, it doesn't go anywhere but straight to these heaters. So how can you possibly get a short appearing? Well, this wire has to be doing something wrong. It's got to be like contacting something. I would really expected there to be a capacitor involved here. Oh boy. Is there any other place for the current to go other than two heaters? Well, they're using dots to show the connections quite clearly. No connection there, nor should there be. So that's it. It's just this wire and then heaters to ground. We've tested the tubes, all the heaters work, nothing is shorted. Okay, well, it's not going to be quite so easy here as it might have been. Hey, by the way, where is this curved line here pointing at the plate? Same thing over here, another curved line pointing here. As if there should be a note written in this white space, but there's no note. See down here? So in a schematic, it's routine to use a curving line for notes and straight lines for everything else, and that way your eye can pick up a note very quickly. You can spot these curvy lines.
very quickly. You can see, tell the note from the wire that way. So these notes are missing. Well, who would steal the notes? I wonder if they're on the
schematic on the lid. No, there's no schematic on the lid. There's just a tube chart. No schematic.
Okay, well, we're going to have just, I don't know what we're going to do. Well, we're going to find out. We're going to do something.
Well, let's see if we can follow some wires, see where they go. So, we'll start on the negative side here. So the contact is insulated away. Is this for sure the negative side? Maybe this isn't even the negative side. The wire comes down. And looks like it's going to disappear from view right away. Nope. There it is. Comes over to the terminal right here. What of it? And I don't see anything weird. There's a bare wire right here. Bare wire. This is a grounded terminal with a bare wire. It's pretty darn close, but it doesn't look to me like it's shorting it. Okay, the other wire. The other wire's here. Going to the switch. This is the kind of thing that could be yanked on or something like that and cause things to rotate or move. But I don't see a problem there. So it's deeper in the circuit. Oh, look at in there. How in heaven's name do you work in there? Even if this... Wow, so up under here. Well, you know what, maybe it separates from this front panel piece somehow with those, they put a couple of those nuts back in. These are terrible, I hate these nuts, these hollow shell nuts, really hard to get on. Hey, it's a pretty strong word, Jim. What are you saying that for? You know why? It's because yesterday it was so terrible trying to fix my drain. I ended up fighting with my wife. Can you believe it? I realized afterwards, what has happened to you, Jim? What are you arguing with her for? The day did not go well yesterday. And that's what's in store for me when I leave here. Go back and start pounding away on that drain. I don't see any reason for it to be acting up. The switch itself. The switch itself. So we're going to take a close look at the switch here. Looks like we can stand it up and operate it. Let me get out the other camera. Oh, the world is turned on its side here. There we go. So I've got fixed focus on. I've got to adjust that. Okay, give me a moment here. Okay, we're going to be able to see him pretty good with this camera. What's happening there? It's losing its wax. Okay, here's the switch. The wire from the battery is the one you see moving now, which goes to the farther terminal. They almost look like they're soldered together there. Ooh, is that the short circuit right there? Can you see it any better? Probably not short circuited.
Gotta do a little better job on the focus here. Okay, let me put it like this. Well, that looks nicely focused. Okay, let's try that.
So I have managed to remove a substantial amount of wax from one of my ears, the one that was working kind of okay. I couldn't believe how much wax is in it. And I'm hearing all kinds of things I haven't heard. I was almost in tears a couple times, realizing how my hearing has been bad for maybe years. Okay, can't quite see if those are in contact. Flashlight, here we are. Let's try again. I can see with my own eyeballs here. So I can see with my own eyes there is no contact in there. So just from looking with a different angle. We'll look with this angle. Wow, I could see the gap. Let's see if those wires wiggle or not. Do they wiggle around? Maybe they were in contact and I uncontacted them already. I don't think so. The terminals aren't going anywhere. So broken insulation on this wire shorting out, that's so unlikely. Well, so generally speaking, a switch can only do two things, open or close. You can see the position it's in right now. See the contact on the left is longer than the contact on the right. The contact on the right should only make contact when the lid is open. So I'm going to open the lid. There's of course no power or anything going on with the radio. Okay, here we go. We'll get that wire out of the way. You jumped in the way there. Here we go. Opening the lid. There you can see the connection being made. Maybe it looks like, altogether is there four? Three. There's three. It looks like three. Yeah, three leads coming up to the switch. And the door closed. Okay, so the top one in the back is out of contact. The bottom one in the back is out of contact. So it's, what it is? It's supplying a ground. I think that's, if I remember right, that's what it does. So the wire that's always in contact is a ground. Well, wait a minute. You can't put a ground. That doesn't make sense. That doesn't make sense. So, okay, so where's that wire go? The wire... You can see why the antenna wire would break off. It's every time you open and close the lid. That happens. Incidentally, I've soldered it back, but I'll bet you that'll come off pretty quick. It's soldered back right now, so that's probably all these radios have suffered that kind of failure. Antenna connection failure. So door closed, no short. Well, it's connecting. Think about it. It's grounded. Is it really grounded? It must be grounded. That's with the door open. I'm going to put an ohm meter on that. Yeah, you know what I'm going to do? I'm going to put an ohm meter on there. And we'll watch the ohm meter action while I open and close the door. So since we don't need this for monitoring the B+ right now, I will use this meter here. Okay, these are the 2 meter leads. Let's give it a check. May not go to 0. It's close enough. Okay, so we put this on where the battery connection is. And the other one is here. Oh, gee, I wonder if I made a... did I generate a short with a clip? open circuit. Oh, the door is open. Wait a second. The door is open. Okay, what have I done wrong? What have I done wrong here? The door's open. How come it draws 1.5 amps out of a battery, but shows what? Shows open circuit. I got two meters mixed up here. No, because I tested them. What happened? Took this out of the box and the problem's gone. Is that what's happened? The problem's gone. I took it out of the box and the problem's gone. Not terribly surprising, but I don't know why. What would be? What would have shorted out? Something shorted out in there? Does this mean we can operate the radio now? Should put the tubes back in and repeat this measurement, and then try to operate the radio again with it out of the cabinet. It could be when I removed it from the cabinet, I removed the short circuit too. Not, and I had no idea what it would be, what it was. Nothing visible. Okay, that's what we'll do. We'll load it up with tubes.
They're going to get another shot at life. Life with old capacitors. Well, because clearing pipes is a big deal to me these days, one of those pipes being, or two of those pipes being my ears, I'm going to show you a product here. I am not trying to promote this product. I don't care about the brand. I wanted to show you the device. I got this off of Amazon here in Canada. It's cheap, and to me it's almost a lifesaver, which is why I'm going to show you this. So once again, I'm not trying to promote this as a particular product, but you can see what it is. There's the name right there. There it is, right there. Now, can you believe it? It's a little tiny camera looking through a lens right in the top here. And this, yes, that's a spoon or a scoop. And you turn this guy on. I think I can turn it on here. It has a light built into the end of it, so it lights up the inside of your ear. And this then wirelessly connects using a Wi-Fi type connection to your cell phone or whatever, so you can see an image. The combination of seeing the image, well, not the combination, yeah, seeing the image and knowing where that spoon thing is, allows you to go in your ear and dig out. This is a horrible thing I'm talking about, but if you're in my age range, and chances are you are, you probably have the same kind of problems I have. I don't have a lot of problems, but this ear thing is a big deal to me. So there's a way out, okay? If I'd known this 5 years ago, I would have had this 5 years ago. I bet you couldn't have bought this. I couldn't believe these things even exist. I mean, we're told all the time, stick nothing bigger than your elbow in your ear, right? But in fact, I put this thing in pretty deep because it has a camera. And definitely works. Definitely works. Like I say, I think there's many brands. I don't really know. Okay, enough of that pipe stuff. Now, I was going to try to operate this guy, but before doing that, I haven't put the tubes in yet. I put the tubes in, and there was something I wanted to do before actually powering it up. Maybe just use the ohm meter. Yeah, let me stick the tubes in, and we'll go from there. Wasn't I going to do that? Well, the tubes are in, the door is open, and the resistance is 0. Wow, it shouldn't really be 0. Wait a minute. The resistance is 2.6 ohms. Probably correct for the tubes that are in here, I'm going to guess. Well, let's close the door and see what happens. And open it again. Just force it open. That's how you do it. Okay, there we go. And there it is again.
even hooking up an ohm meter to these tube heaters is could be a little anxiety inducing. If for some reason your voltmeter works with 9 volts, quickly disconnect this one. No, I don't think this one works with 9, but it might work with, I don't know. I can't remember what's in here. Might be 2 A cells, that'd be 3 volts. Can't remember. So I'm just saying you could burn out these heaters so easily when you're fooling around. And again, it's a painful experience I've had. Don't want to have it again. So situation is, to make sure, situation looks like if we apply power, things are going to be okay. Okay, so I'm going to hook it up through this through the ammeter again. The ammeter's this one, right? So I can let's just keep the video going here. Okay, one on the amp scale, since it was drawing an amp, and we're going to take this clip off here. Here's our battery. Negative side is grounded. Ground side is here. Okay. Now we're going to run this through the meter. Door is open. Power is on. Okay, meter. Wait a minute. Don't I need to? Yeah, the battery's the power gem. Here we go. That looks correct. What was the current draw on those tubes again? Wasn't it 50 milliamps? Was it? Let's take a look. Anybody? How about a 1T5? I think it was, which is in there. A 1T. One S5's in there. This one takes filament volts 1.4 amps, 50 milliamps. So 50 milliamps. So 4 tubes of 50 milliamps each. Hey, it comes out to 200 milliamps. That's what we had here. Good. Exactly why it appeared to be shorted before, I don't know. But we're ready to go and operate this guy. For real. Okay, so we'll make this connection when we want, and the heaters will come on. Next thing to do is to apply high voltage without the heaters on, and see what happens basically. So to do that, I need to do that safely. I need to have this meter hooked up. These are the leads from the high voltage supply here. So we're going to go positive on the red. Okay, and then this has to go to the positive one, which I was basically guessing is the red wire. It's probably a very good guess. And then we want to go here. Wait a minute. I want to change this to voltage over here. And we need the last clip lead. It goes to the other high voltage input. Now, I'm going to leave this open. Battery's open, high voltage is open. I have to turn on my power supply here. Give it a moment. I don't think this zeroes right out either. There's a rectifier tube in there that has to warm up. I have to give it a moment. We will see some voltage here. No, you won't see it up there. Way down here. There we are. We see no voltage. Oh, because I got this on standby. Okay, so I'm going to flip this on. Okay, so we're starting with, well, that's about, no, that looks like 0. Good. So the deal here is how much current is this drawing as I raise the B+, and I'll be watching it on the meter. I'll tip the camera up there too so we can watch the meter. So first we're going to make the connection. Make the connection. Have I done this right? I think so. Okay, remember, no heaters, so there should be no tube current. In fact, as I think I mentioned before, some of these battery operated radios, they leave the high voltage battery connected all the time, because only when the heaters are on is there a current draw on the high voltage battery. So 0.8 volts, that's not going to improve too much. So I'm going to turn this up. Here, why don't you come up here with me? Yeah, this is where I am. I'm way up here all the time. Keep an eye on this meter. If there's a short or something seriously wrong as I crank up the voltage control, which is shown over here, voltage, this will go up. See, the red mark is an indication when you're going to damage this machine. So the normal voltage on here would be 67. So if I just tip this down a little wee bit, you can see that other meter. As I don't put my arm in front of it. Way to go. There we go. We're going up. We're going up now. Look at the current. We're up to 50 volts. So I see zero current on this meter. Now this is 100 milliamps, so if there's a tiny current, it's not going to show here. But, oops. I apologize for that. I just slapped the microphone. That probably woke you up. I could attach the battery at this point, and we'd be playing this radio. That's what we'd be doing. Okay, we could do this. We can do this. So I still have the current meter, which you can't see. Okay, no use looking up there anymore. Come on back down to the midget range here. Okay. 64 big volts on this radio. What else do I have to think of? I have to think about tuning it, and I have to think about controlling its volume, which unfortunately those controls are kind of buried underneath here. You could touch it briefly, but without having checked the volume, that's not going to work very well. And yeah, this will be the lead that I would clip up there. This is the negative is to the negative. You can tell I'm nervous. I am nervous about this. So I think I can lay the radio down this way. Let me crank down this 67 volts here in case I short things out. Just lay it like this. It's actually a piece of sandpaper, but that doesn't matter as long as these things are not contacting each other. Okay, and this guy, wait a minute, something happened. Did we? No. You had too many white clip leads. I'm looking at this thinking they're the same clip lead. They're not. So this is on here, so this comes over here. Now there's something not quite right. Yeah, this is off. Okay, let's put the negative on the negative. Too many wires going around here. Negative on the negative. Okay, I have the negative connection for the A battery. Connect it there and we're in business. Don't connect it yet. So we have no B+, so I'm going to connect this now, and we should see the 200 milliamps or so on here. Good show. Wait, wow, it's like precisely. That's amazing. So now we're going to raise the B+, and this radio should come to life. That's what should happen. So watching the B+ voltage here, should hear something up around 40. That's 6 volts. So okay, so there's a current draw on the supply this time. That's good. Let me go back up. I got a little scared there. We're there. You can hear something happening. Try to tune it. How do you tune it? That's probably something going on here. So I'm watching the current flow. Here, you watch it too. Put this back. Is that staticky from the short coming and going on the battery connection? Extremely sensitive to any change in current on the heater, I think is really what we're seeing here. Okay. Now I was going after the volume control. Here it is. That's probably turned down. There we are. Now I'm going to tune it. It works. Pretty weak. Full volume. Works better at the higher frequencies. Down here it gets quiet, but this is where the stations are. We're not going to hear them. Let's try 680. I thought I heard a voice, or it was my stomach. Scare me. No. Maybe the French one. Now I'm not aiming the antenna. That could also be a... No. Let's try that. So we'll go down around 590. And we'll try... aiming this. I'm scared to turn all this stuff around here. What does that sound? I don't think we're going to get anywhere with that. Okay. Now we're going to shut it off. So the way to do that with all these power supplies is I could just simply break the heater current and then kill the high voltage. Hey, how do you like that, eh? So even with those old capacitors, the radio is working, and maybe out of my shop and in the right position, it might pick up, outdoors and stuff like that. It might actually pick up stations, especially at the higher frequencies where it seemed to be more sensitive. So that's good. That means this is worth investing in. Well, I'm investing a couple capacitors in a bit of time, but the chance of having this work is extremely high. So I'm going to carry on. So I think it's break time. So reduce the excitement in me before I carry on. I started wondering if you could get a battery for this radio. Look at this. This is on Amazon.ca, Canada Amazon. Unfortunately, it says currently, that's a pun, currently unavailable. But there it is, 67.5 volt alkaline battery. So these are, I guess, available somewhere, just not on Amazon Canada right now. That's surprising. I really didn't think you could get these kinds of things. Okay, so it's green lights in every direction here now. Mind you, the battery case for the D cell is busted, so we don't worry about that right now. You can literally solder wires to the top of a battery if you really have to. So the name of the game now is going to be get rid of these capacitors here. 1, 2, count them again. 1, 2, 3, 4, 5, 6. What is special about this one? Why does it have a plus on it? Maybe we can find this on the schematic. Let's do that. The other end, well, it must be connected right. I think it's right. I think the wire's going right through to here. I think. So positive end, and there's no another positive sign, so you can't lose track of it. I can't see what the value is on it. Sprague. Plus signs all around there, so something special about this one. Let's take a look on the schematic, see if we can find it. Okay. So I would be, if I were a big capacitor, I would be right there. 10 microfarads. I think that's a 10 microfarad capacitor there. Wow. A little hard to believe. I can just pull it out a little further here and take a look at it. I cannot. I'd have to cut it out. I don't want to do that right now. Maybe up on the top here. Get a size. No, they've hidden the size out of view. Well, if that's not the 10, well, I mean, there would have to be another. Actually, they don't show this as a polarized capacitor here, but to be 10, it has to be. And what's it on? It's on the screen. So you see they're really killing the signals on the screen here with it. So it kind of makes sense, but physically it's a very, very small capacitor for this vintage, so it doesn't quite make sense. But I don't see any other big capacitors anywhere. I would have thought something like that would be on the heaters somehow, but no. That says suppressor. That's what that says. A suppressor grid. That's what that must say also. Suppressor grid. You have to pay attention to which of these terminals it's connected to. You want to make sure you ground this terminal so it provides the ground to the suppressor, and not flip these around into filament feeds around. That would cause trouble. Not that that's going to happen. Okay, that's great. Voltages should hold within 20% with rated battery voltage. Did I miss any other hints now that will come out and make more sense to me when I see it this time? I don't think so. Offhand. No. No news. Very good. Okay, so those capacitors got to go. I'll start with this one. In fact, you know what? I'm going to flip the camera on. I'm going to go right to it. Camera is flipped on. Okay, now that's a technical video making term. Flipped on. We will cut this guy out. Wire, leave some length. Out you come. Let's cut this too. So this is not soldered into this. There's a terminal strip here. It's not soldered in it. Oh, that's kind of weird. Let's take a look at that with the other camera. That's just a little odd what they've done here. What they've done is they've taken the lead from this capacitor. You see how it's run through? That has to be a mistake. So it is run through there, and then it continues on over to this very solid grounding terminal here, where they were solid ground. But it's running through, this is a grounded point also. That you can see that the terminal strip is, you would just think they would solder that too. But they did not. They did not. Well, in response to that, I'm going to cut this wire right in here. Pull out the capacitor and find out 10. It's a 10. Oh, a 60 volt. That's why it's so small. 10. Okay, well, no surprise because we saw it on the schematic. Hey, is this any good? Electrolytic, this is electrolytic. It must be pretty tough to test one like this and get a result that is believable. Now, I just bent that lead a touch, but I don't think I cracked all that. That's not a good sign. Yeah, same thing here. It's cracking probably from shrinkage. And I may have cracked it, pulling it out. Well, let's give them a test. You know what? I got a little tester here. We'll use the little tester. Small tester, very powerful. When I was in college, if somebody had walked in with one of these, holy smokes, the professors would have stopped the course. Okay, here we go. So it says it's 1,000 picofarads. 1,000 picofarads is 1 nanofarad. Is 0.001. Ooh, where is the capacitance in there? Look at the V loss is 0. What does that say? That's almost saying one of these connections is no longer connected inside the capacitor. I don't know. Do you believe that? Let's run it again. Almost exactly the same number. So this is a bad guy. According to this tester, he's bad. Way off. Way off. It's as if it's nothing there. What that would do in the radio, it would fail to quell the signals that might be traveling on the screen. The signals will travel between tubes, and you're going to get a feedback thing going. And you'd think the radio would howl and scream, but it didn't. It actually worked. It just seemed a little quiet. Huh. Well, okay, let's give it another test. Just call me Curious George here. We'll test him on this tester. Now again, this is an electrolytic capacitor. I need to flip this switch. It calibrates the unit for electrolytic, but how calibrated is it really? All electrolytics leak a little wee bit, at least old ones, even when they're new. So we're going to hit this with 50 volts. This is a 60 volt capacitor. This is the only test I can do. 50 volt test. We'll see what the eye does. Oh, just look at it. See how fast it jumped open? Can you see that? It's just going boom, boom, boom. That also is an indicator. Like this should charge up. The eye should close and then come open. It should charge up. So the suggestion here also is that there's zero capacitance in this capacitor, probably a broken lead. So the two tests are suggesting the same thing. I don't know that there's another test I can do. I don't think there is another test I can do. And oddly enough, the radio worked. Literally, it would work now with this out of the circuit, I would think. Well, I'm going to put in a nice electrolytic 10 microfarad capacitor in there. And
and that'll be over. Okay, so I've put in a new 10 here. 10, and Jim, what's the voltage rating on that? Did you even look? 400 volts, so only have to get to 60. A little bit of overkill there, but that won't matter. Now look at the rest of these capacitors. These ones may or may not have the actual value written on them. What they have is this weird serial number. Can you read it? It's upside down. 0270037 something or other. I don't know what that is. It's possible that I have to figure out every one of these capacitors' location and go by the schematic to get the value, as opposed to just reading it off the capacitor. So I think for today, because I have other jobs waiting for me, I'm going to call it quits here. I'm not going to operate the radio. I'm just going to have done this one capacitor, and tomorrow I will slug away at these, and maybe even later today come in and do a couple of these, figure out what they are, and then replace them. So hopefully, there's another one down here. With all those replaced, the radio is going to work quite well. It worked surprisingly well the way it was, even though we didn't hear anything. Okay, well, thanks a lot for watching. Today I'm off to fiddle with various pipes. See ya.